Okay, I guess others don't want to join again. So for the second half, this I'm sharing with you. So yeah, in NQ function, what's happening here? First, we are checking the overflow condition. How we are doing it? Checking whether real equal to max minus 1. That means it's checking whether your stack queue is already full or not. Max minus 1 is the total number of items inside the queue. So first checking if front equal to minus 1. That means if your queue is initially empty, so you will simply increment the value of front, or you will just set it to 0. I guess so also it's already written. Whenever you want to add one item, you are going to enqueue it from the rear side, correct? So if you want to enqueue from the rear side, what will happen? Initially, your queue is empty. So first item you want to add, so you will increment the front as 0 because after you added one element, your front will be the next available position. So front is 0 here. And since you will add all the items from the rear end, so every time you add one item, you will increment the value of rear to the next available position. Correct? Same thing is happening here. So if front equal to minus 1, that means queue is initially empty, you will just set front equal to 0. Then after inserting the item into the queue, you will set the rear value to rear plus 1. Then after that, you will just add item to the position pointed out by the rear. What's happening in DQ? Again, you are checking the underflow condition. If front equal to minus 1 or front greater than rear. So, if your queue is already empty, that means that's an underflow condition. So, what you will do? You will do nothing. Then, next condition is if it's not the underflow condition, you will simply delete the item. Which item will be deleted? The front item will be deleted from the queue. So it will simply delete the front item. And after deleting the item, you will just set your value front equal to front plus 1. So here after deleting it, you will set your front equal to front plus 1. You will just show it to the next value. Alright. So it's same. So for displaying, you are just displaying. So from this program, you can see in NQ operation, there is no comparison involved. So it's a constant thing. Therefore, the time complexity for NQ operation is 1. Correct? There is no comparison involved. Everything is just single one step. Here, just you are comparing it whether the rear with the max minus 1 or not. Right? Again, here it's checking this one item front equal to minus 1 or not. Correct? Here also just adding the item. Same thing is deleting. You are just deleting the front item. So for NQ and DQ, complexity is constant. That means O1. Now tell me what's the complexity for the display function. What's the complexity for the display function? See carefully and tell me.
Ma'am,
Sorry, what did you say?
ma'am, your question, can you repeat again?
I'm asking what will be the time complexity for the display function. I explained how time complexity for NQ and DQ is constant time, therefore O1. No comparison involved here, just single step thing.
Mm.
So what will be the time complexity for display function? See the function carefully, then tell.
And
Yes, Deepa, what did you say?
and
Correct. How did you get it? And
ma'am, there is the comparison if front equal to minus one. Not comparison. Assign
yeah,
assigning, and there's also another for loop in the second else. That's why n.
correct. So in this program, you can see there is only one for loop, right? If there is a if else condition, so if part will be added, then the else part will be added, correct? Inside the if portion, there is a single step. That means that there's the constant time. Now in the else part, you have a for loop here. For a single for loop, if you guys remember, the time complexity is always n because there are n number of comparisons. So the time complexity for this display function is n o n. It will be constant time plus maybe some 3 and plus something something. Ultimately, we just ignore all those constant terms and insignificant terms. So time complexity is O n. Is it clear to others? Abdullah, Dular, is it clear? Time complexity for display function. Iba said yes. Abdullah said yes. Dular, CR, is it clear? Fatma said yes. Okay. Dular, CR, noted. So Abdullah, Iba, and Tanmay and Iba clear how the time complexity of display function is n and how others are just 111. So this is very simple program, even shorter than your stack. In stack, we even check like is empty, is full, P, and all. In Q, there is just two main operations, NQ and TQ. And to check the overflow and underflow condition, we are just using simple if statement, not using function. In the stack program, we use additional functions to check underflow and overflow condition, correct? So if you want, you can also modify your previous program stack in this manner. It's up to you. So Q implementation is clear to all the program. So, my queue is 463. There are four elements. If I want to delete the item, okay. Lost its connection. Anyway, I guess you guys understood the program. Is it yes? Give implementation function with the operations. Okay, if yes, I'll just end the meeting. I take the attendance and I end the meeting now. So if next time I ask about function definition, declaration, prototyping, don't say didn't understand, okay? When you write program, always try to see what's happening where. What is happening, how is it happening, and what are the consequences of any functions if you are using a function. Always try to understand the program. Okay? Okay. I'm ending your lab class now. Next class we will see what program you can do. Okay? Okay. Bye. Thank you.